Good day, this is Professor Will, CBMD PhD case, Saturday, May 9th, 2020. It is 6:10:33 seconds a.m. Eastern Standard Time, and this is a continuation of my Corona series, so let's get started here. Trial drug can significantly block early stages of COVID-19 in engineered human tissues. Date, April 2nd, 2020. Source, University of British Columbia. Summary. An international team has found a trial drug that effectively blocks cellular door SARS-CoV-2 uses to infect its host. The findings published today in Cell hold promise as a treatment capable of stopping early infection with the novel coronavirus that as of April 2nd has affected more than 981,000 people and claimed the lives of 50,000 people worldwide. The study provides new insights into key aspects of SARS-CoV-2, the virus that causes COVID-19, and its interactions on a cellular level, as well as how the virus can infect blood vessels and kidney. We are hopeful our results have implications for the development of a novel drug for the treatment of this unprecedented pandemic. ACE2, a protein on the surface of the cell membrane, is now at the center stage in this outbreak as the key receptor for the spike glycoprotein of SARS-CoV-2. Researchers at the University of Toronto and the Institute of Molecular Biology first identified ACE2 and found that in living organisms, ACE2 is the key receptor for SARS, the viral respiratory illness recognized as a global threat in 2003. His laboratory also went on to link the protein to both cardiovascular disease and lung failure. While the COVID-19 outbreak continues to spread around the globe, the absence of a clinically proven antiviral therapy or a treatment specifically targeting the critical SARS-CoV-2 receptor ACE2 on a molecular level has meant an empty arsenal for healthcare providers struggling to treat severe cases of COVID-19. Our new study provides very much needed direct evidence that a drug called APN-01, human recombinant soluble angiotensin converting enzyme 2, HRS-ACE2, soon to be tested in clinical trials by European biotech company Apeiron Biologics, is useful as an antiviral therapy for COVID-19. In cell cultures analyzed in the current study, HRS-ACE2 inhibited the coronavirus load by a factor of 1,000 to 5,000. In engineered replicas of human blood vessels and kidneys, organoids grown from human stem cells, the researchers demonstrated that the virus can directly infect and duplicate itself in these tissues. This provides important information on the development of the disease and in fact a severe case of COVID-19 present with multi-organ failure and evidence of cardiovascular damage. Clinical grade HRS-ACE2 also reduced the SARS-CoV-2 infection in these engineered human tissue. Using organoids allows us to test in a very agile way treatments that are already being used for other diseases or that are close to being validated. In these moments in which time is short, human organoids save the time that we would spend to test a new drug in the human setting. The virus causing COVID-19 is a close sibling to the first SARS virus. Our previous work has helped to rapidly identify ACE2 as the entry gate for SARS-CoV-2, which explains a lot about the disease. Now we know that a soluble form of ACE2 that catches the virus away could be indeed a very rational therapy that specifically targets the gate the virus must take to infect us. There is hope for this horrible pandemic. Canadian study finds temperature latitude not associated with COVID-19 spread. School closures, physical distancing, and public health measures have effect. Date, May 8, 2020. Source, Canadian Medical Association Journal. Summary. A new study finds that temperature and latitude do not appear to be associated with the spread of coronavirus disease 2019, COVID-19, but school closures and other public health measures are having a positive effect. Our study provides important new evidence using global data from the COVID-19 epidemic that these public health interventions have reduced epidemic growth. The Canadian study looked at 144 geopolitical areas, states, and provinces in Australia, the United States and Canada, as well as various countries around the world, and a total of more than 375,600 confirmed COVID-19 cases. China, Italy, Iran, and South Korea were excluded because the virus was either waning in the case of China or in full disease outbreak at the time of the analysis in others. To estimate epidemic growth, researchers compared the number of cases on March 27th with cases on March 20, 2020, and determined the influence of latitude, temperature, humidity, school closures, restrictions of mass gatherings, and social distancing, measured during the exposure period of March 7th to 13th. They found little or no association between latitude or temperature, with epidemic growth of COVID-19 and a weak association between humidity and reduced transmission. The results that hotter weather had no effect on the pandemic's progression surprised the author. We had conducted a preliminary study that suggested both latitude and temperature could play a role, but when we repeated the study under much more rigorous conditions, we got the opposite result. The researchers did find that public health measures, including school closures, social distancing, and restrictions of large gatherings, have been effective. Our results of immediate relevance, as many countries and some Canadian provinces and territories are considering easing or removing some of these public health interventions. Summer is not going to make this go away. It is important people know that, on the other hand, the more public health interventions an area had in place, the bigger the impact on slowing the epidemic growth. These public health interventions are really important because they are the only thing working right now to slow the epidemic. The authors note several study limitations such as differences in testing practices, the inability to estimate actual rates of COVID-19, and compliance with social distancing. When deciding how to lift restrictions, government's public health authorities should carefully weigh the impact of these measures against potential economic and mental health harms and benefits. Some COVID-19 patients still have coronavirus after symptoms disappear. Date March 27, 2020. Source American Thoracic Society. Summary: researchers found that half of the patients they treated for mild COVID-19 infection still had coronavirus for up to 8 days after symptoms disappeared. Researchers collected samples from throat swabs taken from all patients on alternate days and analyzed. Patients were discharged after their recovery and confirmation of negative viral status by at least 2 consecutive polymerase chain reaction PCR tests. The most significant finding from our study is that half of the patients kept shedding the virus even after resolution of their symptoms. More severe infections may have even longer shedding time. The primary symptoms in these patients include fever, cough, pain, and pharyngalgia, and difficult and labored breathing, dyspnea. Patients were treated with a range of medications. The time from infection to onset symptoms incubation period was 5 days among all but one patient. The average duration of symptoms was 8 days, while the length of time patients remained contagious after the end of their symptoms ranged from 1 to 8 days. 2 patients had diabetes, and 1 had tuberculosis, neither of which affected the timing of the course of COVID-19 infection. If you had mild respiratory symptoms from COVID-19 or were staying at home so as not to infect people, extend your quarantine for another 2 weeks after recovery to ensure that you don't infect other people. The authors had a specific message for the medical community. COVID-19 patients can be infectious even after their symptomatic recovery, so treat the asymptomatic recently recovered patients as carefully as symptomatic patients. The researchers emphasized that all these patients had milder infections and recovered from the disease, and that the study looked at a small number of patients. They noted that it is unclear whether similar results would hold true for more vulnerable patients such as the elderly, those with suppressed immune systems, and patients on immunosuppressive therapy. Further studies are needed to investigate if the real-time PCR detected virus is capable of transmission in the later stages of COVID-19 infection. Good day, this is Professor Will, CBMD PhD on infectious disease and microbiology. Well, I hope you enjoyed listening and have a great day.